Welcome to the DIY Honda Garage channel. The DTC P0706 indicates a transmission range switch open issue specific to Honda Accord models from 2012 to 2017. This diagnostic trouble code signifies a malfunction within the electrical circuit responsible for the transmission range switch. It is important to note that this fault is purely electrical. Mechanical issues within the transmission do not contribute to this DTC. The transmission range switch itself plays a significant role as it communicates the position of the gearshift lever to the vehicle's engine control unit, ECU. Proper function of this component is vital for smooth gear selection and overall vehicle operation. Diagnosing this code requires a methodical approach to identify potential failures in the related circuits and components. After completing all the requisite troubleshooting steps and performing necessary repairs, final verification is critical. Begin by meticulously reconnecting all the components that were previously disconnected during the diagnostic process. Once everything is securely reconnected, the next step involves clearing the diagnostic trouble codes, DTCs, using the Honda Diagnostic System, HDS. This step resets any warnings the vehicle may have triggered during the troubleshooting process. Finally, it is essential to conduct a test drive to ensure that the vehicle operates smoothly without re-triggering the P0706 code. Monitoring the shifting performance and observing if the check engine light illuminates again during this test drive will confirm the effectiveness of the repairs made. To ensure ongoing reliability and prevent recurrence of the P0706 code, regular preventive maintenance is essential. Start by routinely inspecting the wiring associated with the transmission range switch, as fraying or exposure can lead to electrical faults. Additionally, checking the shift cable adjustments on a periodic basis can help maintain proper communication between the gear shift lever and the transmission range switch. Moreover, updates to the vehicle's PCM software should be conducted whenever available, as improved versions may enhance the overall functionality and responsiveness of the vehicle's electronic components. By incorporating these preventive measures, you can minimize the risk of electrical issues arising in the transmission range switch circuit. In conclusion, understanding DTC P0706 and its implications is vital for maintaining the performance of a Honda Accord from 2012 to 2017. This code highlights the necessity of careful diagnosis, focusing on the electrical circuit tied to the transmission range switch. Throughout the troubleshooting process, key steps include verifying the shift cable adjustment, checking transmission range switch signals, and verifying continuity of associated wiring. By strictly following these diagnostic steps, you can accurately pinpoint failures contributing to the DTC, whether they be with the switch itself or the wiring. Implementing preventive maintenance practices ensures ongoing reliability, reducing chances of electrical errors re-emerging in the future. Ultimately, being informed and methodical in addressing faults such as the P0706 will lead to better vehicle performance and longevity. The primary component tied to DTC P0706 is the transmission range switch, which is strategically positioned on the side of the transmission housing. This component plays a crucial role in informing the engine control unit, ECU, about the current position of the gear shift lever, whether it is in park, reverse, neutral, drive, or other gear selections. Understanding how this switch operates is essential, as it affects various functionalities, including safety protocols and optimal engine performance. Given its location, if there are any issues with the switch or its wiring harness, it could lead to an open circuit, which triggers the DTC P0706. This code emphasizes that the issue is not due to a mechanical failure in the transmission, but rather due to electrical complications that need to be rectified for proper vehicle operation. There are several possible causes for the P0706 DTC being triggered. First, an improper adjustment of the shift cable may prevent the transmission range switch from signaling accurately, which can lead to discrepancies in the gear positions recognized by the ECU. Secondly, a faulty transmission range switch itself can cause the circuit to open, resulting in a loss of communication with the ECU and the triggering of the DTC. Finally, wiring issues, such as frayed wires or poor connections in the transmission range switch circuit, can also cause the switch to fail to send the proper signals, thus generating this fault code. Each of these possible causes necessitates careful inspection and testing as part of the troubleshooting process. When dealing with the P0706 DTC, several symptoms may arise indicating a problematic transmission range switch. One notable symptom is poor shifting performance, where drivers may experience hesitation or rough transitions between gears. In more severe instances, the vehicle might become unable to shift into certain gears altogether, rendering the car inoperable in specific situations. Additionally, the check engine light will illuminate on the dashboard, signaling there is an issue that requires attention. All these indicators serve as an essential alert for the driver, prompting them to seek immediate diagnosis to avoid further complications or safety concerns. Troubleshooting for P0706 begins with problem verification. First, it is crucial to ensure that the shift cable is properly adjusted as an initial step in the diagnostic process. Misalignment in this part can lead to incorrect signals being sent to the engine control unit, ECU. Next, the ignition switch should be turned to the on position, or the engine start-stop button pressed to enter the on mode. After this, the next action involves using the Honda Diagnostics System, HDS, to compare the transmission range switch signal inputs with a predetermined table that outlines expected values for each gear position. This comparison will instantly highlight discrepancies, setting the stage for further investigation into the circuitry and components involved. Continuing with troubleshooting step 2, the focus shifts to detailed signal checking of the transmission range switch. This step involves comparing the transmission range switch signal inputs from the HDS against the specified table for each shift lever position. It is vital to ensure that the signals align with what is expected. Discrepancies indicate potential issues in the system. If all signals remain off, then the diagnostic procedure progresses to the next steps dedicated to finding any exposed circuits. Conversely, if any signals do not match the expected results, this prompts a detailed inspection of the transmission range switch and its connections. This meticulous approach allows for accurate identification of whether the issue resides with the switch itself or within its circuit. Step 3 in troubleshooting the P0706 code involves a more hands-on approach by checking the transmission range switch directly. First, you need to turn the ignition switch to the off mode or lock position to ensure safety while working on the electrical components. Then, disconnect the transmission range switch 10P connector to isolate it from the circuit. A jumper wire is used to connect the terminal of the switch that failed to indicate on in the previous steps to the body ground. This direct testing allows you to examine whether grounding affects the switch operation. Following this connection, turning the ignition key to the on position will enable further checks to see if the range switch outputs a signal indicating on. Successful indication would imply the switch's fault, while a lack thereof will confirm that the switch is functioning correctly. In the fourth troubleshooting step, the focus shifts towards checking for open circuits within the wires connected to the transmission range switch. Begin by turning the ignition switch to the off position to ensure safe handling of the electrical components. Jumping the SCS line with the HDS is the next action, setting up a baseline for continuity checks. Then, disconnect the PCM connector to avoid false readings during your tests. The next critical step is to check for continuity between the output terminals of the transmission range switch 10P connector and their corresponding PCM terminals, as specified in the diagnostic table. Confirming continuity here indicates that there is no break in the wiring, while a lack of continuity would signify an open circuit, requiring repairs to restore the proper function of the transmission range switch system. The final step involves a detailed examination of the power ground PG wire continuity. First, turn the ignition switch to the off position to ensure a safe working environment. Disconnect the transmission range switch 10P connector to isolate the system from the vehicle's electrical network. A continuity test is then performed between the test points designed to examine the PG wire. If continuity exists, it signifies that the wire is intact and functional, indicating a need to replace the transmission range switch as the next logical course of action. Conversely, if continuity is absent, it suggests the presence of an open wire between the transmission range switch and ground, necessitating repairs either to the wire itself or to the body ground point, thereby restoring proper functionality to the entire circuit. Please like and subscribe to the channel. See you next time.